then yeah, I saw the AI companion.
How does Zoom have Zoom windows that share in your screen sharing? Is this because you're
so
on Linux?
That front one is you only. Like I'm not seeing the acknowledgement required. So I guess the participants have to acknowledge.
Oh, this is us. No, but I'm talking about this.
Yeah, I did the acknowledge on my side, so I guess on the other computer you need to do acknowledge too.
Like,
There you go.
I shouldn't be able to see your Zoom toolbars. You know what I mean?
Yeah, I know what you mean. I've only seen that on Linux.
That's so weird.
I use Mac all the time at work, and I do this all the time at work. And
Oh, it doesn't do it?
no.
Oh yeah.
No, Zoom knows how to hide everything correctly on the other OSs, but Linux is different. I thought this was interesting though. So they give an example of you have a hash with some keys. One of the keys is an array, and you want to find, in this case, you want to find a user with a role of moderators here. Usually you use the find method from enumerator and get your moderator, and then you can print the email out of that. And but now you can use pattern matching in Ruby. So instead of doing the find syntax, you can just basically assign it to this email variable. So it will create, if this hash exists in the list, it will set the email variable. And it doesn't, I tested this, it doesn't matter how many other keys are in there. So as long as there is a hash in there with some email and a role of moderator, it will match. And the masters are saying, like, just match on any other item that might be in there. So that's why I was able to just print email here. And so I tried it. I wanted to see that it worked. So scratch file that I have open. Here we go. So if I go into IRB, I can copy this system hash in. So there's our system. I'm going to pump up that font tab. Do that. There we go. Cool. So instead of doing the find, I can do the basically it's your hash. You use the hash rocket, and then you give it another hash of what you want to match against. So copying that over, it returned nil, but I now have an email that I didn't explicitly set. It was just defined in the matching hash. So I thought that was just a neat shorthand. I'm still used to using find and all the enumeration functions. Probably what I'd still lean into, but it's nice to know that there's a shorthand for this.
I wonder if there's a performance difference between the two.
Yeah, I do too. There is an error difference. So like if you do if I said moderator, let's change this to let's set moderator, and then we do like moderator 2. No, it's not. That's not one. That'll still return nil. It will throw an error if it can't match. Oh, I know what it was. So like if I sent email to like user@example.com, right? I previously set email before, but I reset it here. If I try to pattern match on it, and it already exists as something else, then this will throw an exception. It'll throw an exception. Saw it earlier. Let me reset it. Maybe I don't fully understand it. I saw it earlier. There's a pattern match error. So if I do email, it is user@example. Then I do try to pattern match on it. Email. No, it reset it that time. Okay. Well, never mind. Yeah, but yeah, to your point, I wonder if there's a performance difference with that. So for tonight, I have a notebook actually, but I have a lot of, I didn't have time to put together slides for this, but I do have some content I kind of want to cover in order. All right, so I'm going to talk about HTTP, just kind of the history of things and how HTTP is structured and requests are structured. Trying to just set the stage for API development and API best practices. A lot of the stuff everyone in this group is probably already well familiar with, but we'll go over the basics, and if anything stands out and want to explore it more or comment on it, let me know. So HTTP stands for Hypertext Transfer Protocol, and we'll just jump over to here. So we talk about Hypertext Transfer Protocol, specifically what it was made for is, well, transferring hypertext. Well, what is hypertext? Hypertext is text that's specific. It's structured text that's nonlinear, and it's meant to include links to other documents. So if we go to any web page and we say, do a search for Wikipedia, right? We're going to get a list of links. We can click on them. It's going to take us to those documents, and then within here, this is going to have links to other things, right? And so that's kind of what hypertext is. But it's not limited to text strictly. It also includes images and video and audio. We can include various things in there. And researching in this, I thought that I originally thought hypertext was more or less an invention of the web, but going back to Wikipedia, there was this thing in 1960 called, I might butcher the pronunciation, but Project Xanadu, or Xanadu.
You got it right.
Got it. Heard it before. So it's the first hypertext project founded in 1960 by Ted Nelson. And I guess there's still some, maybe still some use to it, but I thought this was interesting that before the web even became a thing, hypertext was being talked about or being worked on. So this is important because most HTTP requests are transferring HTML still. We use HTTP a lot for other things, but by and large, most requests that you do, especially in web browsers, you're requesting HTML. You might be even, you're at least requesting HTML from a browser, and you're receiving that in a response. But as everyone here is familiar with, we have these things called APIs, and so we have different types of data that can be transmitted. So we look up MIME types, and we're going to be looking at a lot of these MDN pages tonight. It's a good resource. So we have common media types, and we have these are various media things that can be transmitted over HTTP. And so we have essentially the file and the MIME type name. So a lot of us are probably familiar with text HTML, different images, JavaScript, JSON, and then different audio and image formats. So to start looking at some HTTP examples, one of the easiest things you can do on a web browser, and this works in Firefox and Google Chrome, is Control-Shift-C or Command-Shift-C if you're on Mac. And this will bring up some kind of inspector window. Initially, it will show the HTML that's on the page that you're currently on. We can go to a console and run JavaScript if we want, and then what we're interested in tonight is the network tab. So we see different types that we might want to filter on. So by default, we get all. You might want to see just the HTML requests or just the CSS or JS assets. XHR is going to be network requests that the browser made. But if we refresh this, we're going to see probably a whole slew of requests. A lot of it is JavaScript assets, images. But if we go to the top, we should see an HTML document. And here's our request. And I'm going to scroll down just a little bit so you can see some more detail. So we get the address of the request. We get the HTTP method. It was a GET request to this developer Mozilla.org. Common types. The status is actually a 304, which is a redirect. And then we have some headers we'll talk about later. So the request would include any data that we pass along to it, but it was just a simple GET request. We didn't pass in any data. The response is HTML. So this actually shows the HTML as it was sent. You know, on the page it's styled because we already had this is rendered after we got all of our CSS and JavaScript assets, but here we're just looking at the raw response. And in fact, we can toggle this raw thing here and see exactly in code what we got back. And here's just what would render if we didn't have any CSS or JavaScript to prettify this, basically. So, yeah, headers, request, and response is where I usually live in all these. We'll talk about headers in a bit. I think we talk about headers now a little bit. Some of the common ones we're going to see. The accept header, it's the header that in the requests we pass along to the server to tell the server what kind of formats the client, in this case the web browser, accepts. And then in the response, I don't know why they didn't send one here, but we usually see content type, which that tells the client what kind of message this is. So we just got plain HTML, so there's probably not much the browser needs to know. So I guess it's why it's excluded. It's either excluded or it's hidden. So let's close this out, and then we'll talk about an HTTP session. So let's see. We're going to start with this. Start getting my bearings here. So in HTTP, a client must initiate a request to a server. It's always the general workflow is the client knowing where the server is, makes a request to the server acknowledges the request data connection is established. The client sends a message, the server sends a response, and then we're pretty much done. And so what I was looking for is, there's a note here on HTTP 1.1. It used to be the case when the server sent its response that the connection would then be closed. That is not strictly the case anymore. I'm a little lost at this page, but links are here. But the connection can remain open now, and that's useful for different requests being made. So you might request the HTML, you might request the CSS, and then you might request the JavaScript. And as you saw on the other page, there's a lot of assets. So keeping that connection open can help make that faster. So the structure of a message, this is where we're going to start scrolling down here. Actually, that means this page. This is what I was looking for initially. Yeah. So an HTTP message, it's made up of a start line, headers. Those two combined are called the head. After the head, there's an empty line, and then there's an optional body. So in their example here, they have the start line making a post request to slash the root path. They put the host in the headers. The start line can include the host, but it's also common for it to be as a host header below. But it's a post request to the root path using the HTTP 1.1 protocol. We have host header, a user agent. The accept header is saying that we accept all types of responses. Content type, we're sending JSON, and then the content length is 345. So in the body, we see we have a JSON payload, and then the response, the HTTP version comes first, then a response code, and then a reason, and then we have a slew of headers as well. So the server version, date, content length again, content type. So in this case, they return HTML, and then a cache control saying that they're not caching it. So then their response, they return HTML. So then here's an example of a request again. The request can include query parameters. So this is actually a form example, but here they're posting a form. And then going back to headers, there's two types of headers. There's for the request, there's request headers and there's representation headers. I'm trying to find the links to those. Yeah, here we go. So request headers, they provide the context of the request, and then representation headers, they describe, they basically describe the message. So content type is describing that we have a JSON message in a response, but the request header user agent is saying that we're, in this case, they're using curl. So two different types of headers there. And then the body is included in most responses. It's not always included in it's not always included in requests, but it's included in most responses. If you're including a body in a request, it must be a post, patch, or put. It can't be a get. I might have seen it before in gets, but they're not supposed to be. And then I think that was all I wanted to cover here. Went over response headers, response body. Okay, so then we have status codes. So we have different groups. The numbers, if you come to this page, you'll see what the numbers correspond to. And there's many other pages on the internet that describe the different codes. But it's all, the number series means something. So 200 is going to be your success responses. 300 series is going to be redirects. 400 is in indicates a client error, and 500 indicates a server error. So, and your most common ones are going to be, I think, 200, 201, 204, 304 a lot, 307, 400 is very common, 401 is very common, 403. 401 and 403 are similar. 401 you typically see if you're not authenticated, you're trying to request a resource that requires authentication. 403 can mean that you're authenticated, but you just don't have the authorization to view that resource. 404, I'm very familiar with that. We try to find a resource that doesn't exist or can't be found. Let's see if any others. That one's always a funny one. 418 CPOT. 429 you get optional rate limits. And then in your 500s, I usually only see 500 itself. There are some others, but yeah, these all indicate server errors. So that's the basics of HTTP. Next thing I wanted to go over is, well, great. How do we utilize this in different formats or different contexts? So what we're looking at right now is a browser. So we're going to an address. We're making an HTTP request. We're getting a response. So we're showing the response to that in the browser window. But there's many other methods we can use to make requests. So you go to the command line. We have something called curl. So you can type the command curl, give it the type of request, URL, any headers, and any data. So in this example, we're using this JSON site. It's a basically full mock CRUD API. So I can just copy this, we'll expand that a bit, clear, and then we see we posted the request and it gave us a response. It gave us a response in JSON, so that's why we see that. If we want to see more detail, we can pass in -v for verbose. So it gives us a lot more info. So it'll tell us that, okay, here's our final response, but we see also that the connection is still technically intact. So you make more requests if we needed to. There's various headers here. It's a little hard to see the end of the request headers and the beginning of the response headers, but here's the response headers, and then if I scroll just a tad, you can see the request headers. So we have our host, our user agent, content type. Actually, that's the limited response content. No, that's the request. We're accepting everything the user agent's curl. What I thought was interesting about curl is, if we scroll up here, we see unnecessary use of -x or -- request post. So in curl, if you give it a body, by default, the request method will be post. Obviously, if you wanted to use put or patch, you'd have to specify that, but excluding that will still yield a valid post request. That's using it in browsers. Another common tool you'll see, especially if you're doing API development or you want to test APIs, is Postman. I don't have Postman installed on this machine. I have an alternative called Bruno, which functions pretty much the same as Postman. The main difference is all the requests are saved locally. You don't need to sign up for an account.
That's cool. I use somebody got me to use Insomnia, which is nice, but I think it's an Electron app.
What's it called?
Insomnia.
Oh, Insomnia.
And
Okay.
then all of a sudden it started making me sign in to save things and.
Yeah, I didn't want to mess with that. So I found this to be a pretty lightweight app. It works cross-platform. So I'm running Ubuntu Linux right now. Works fine on here. Works fine on the Mac. But so tools like this, you'll typically create a collection request. You can come to some option, create collection. It'll usually prompt you to give it a name, and in this case, because it's all local, it's going to prompt me for a folder to save it to. All these are just in a Bruno folder in my home directory. In fact, we can probably just do like ls Bruno OC.
Yeah, what do the files look like? Is it just storing as like plain text?
Let's do get product, cap that. I haven't actually looked at this before. Okay, so it's just a configuration file. So whenever I open one of these requests, I'm going to run the same request that I ran with curl. It's just sending, this is creating a product essentially, same URL. It's been a little bit since I've looked at Postman, but essentially what you're doing here is you're creating a saved configuration for making a request. So you can give it a body, you select the HTTP method. You can give it the full URL, or if you're in a collection like this, what I probably should have done is created a variable. So I could have done something like host right now because I haven't created the thing, but then I came here, set a variable, host. I should copy that actually. Do that? Nope. Well, it's not saved, so. That again. Here. Oh, that's headers. Yeah, so typically we do something like that. You can include variables, you can include common headers. So if you're dealing with an authenticated API, you can put your headers in here and they'll get passed along every request. Then coming back here, we typically do your host address and then the path. And then I can save that whenever I want, and then I can run it, and it's going to come back with a response. I look at the headers here. Here's the response headers. So it tells us it was a JSON content type. And then there's some other information here as well. I love this powered by cats on keyboards. I don't know what that's about, but it's there. Then we can set request headers here if we want as well. I haven't looked at the test one. I have seen in most of these applications that you can write scripts that are either run before or after. So I think there's a way to like test and verify your APIs through this, which I think is cool. So I'll often use this to construct curl statements as well, but usually, and I'm going to forget where this is now. I think it's in here, generate code. So you can, so once you construct your request, you can convert it to a shell command, curl, http, wget, and then you can copy that over. And so I've been on teams where I've had to coordinate with front-end teams essentially that say, hey, we're having a problem with the API, but they don't have all the details. And I'm saying like, okay, well, here's the request that I'm testing, and either, hey, I verified the bug, or I haven't verified the bug, this is what I'm running, can you confirm that your client is sending a similar request, and then we'll typically work from there. So that can be very useful. Have the ability to create curl commands and have other people test them, especially in different environments.
Could you go back to that?
Sure.
If you pull down the shell, do you get like the normal list of other languages? Yeah. So like if you go to Ruby, it'll actually do the HTTP get.
Yes. Good catch. Yeah. So you can pick your language.
Yeah.
And they're all using the native implementations too, so.
Yep.
And HTTP is the default Ruby one. That is neat. Even has Faraday in here too. Cool. Well, going to be the next thing I cover is the different Ruby clients. I forget, do I have that open here? Oh, where is this? That's the wrong one. Okay. Actually, it is this folder. So as you just saw, the default HTTP client in Ruby is net HTTP. So also get products, good product. So you can open up any IRB console today, and you should have require net HTTP, and that'll come back true. You should already have it. So with that, you can make requests with it. It does expect URIs. So this is just, you give the address of what you want to request, and it has some other functionality. I haven't dove too deep into this, but once you construct the URI, you can say what is the host, or what are the queries, or what is the path, right? So you get details on the elements of the address path, essentially, and then with that in place, I can run the get request. If I run get by itself, it's just going to give me the raw response body. So in this case, I got a JSON response, still as a string, still serialized. That's not all the information, so you can do get response instead, and the response will have the body contained within it, but I can also see the code, I can see this is where it's a little unintuitive, but you can do to hash, and it will show all the response headers. And then, let's see what else.
If you just call response.headers, what does it give you? Is it a hash or an array?
It's a hash. So you can call the response class as a.
Yeah, but if you just call response.headers.
It doesn't. There's no headers, and header is this thing.
Oh, interesting.
Yeah. So I too, when I saw this, I was like, I kind of expected it to be
because all
self-contained in its own thing. Because like now they have the code as a method, right? Do they have status as a reason? They don't.
No. This is what always gets me to, like, status codes are always numbers, but they always are returned as strings.
They start with what?
They're always they're defined as numbers.
Right, the codes are
But
numbers.
they're always returned as a string.
Yeah.
Always weird me out.
Yeah, I'm guessing they're just parsing that out of the message, right?
Could be.
Because and there's no way to, unless without diving deep into the code to see what's going on. Like, everything's going to be theoretically in this type of format, right? You're going to have a response. It's probably all a string to begin with.
Yeah.
And you're reading the start line, essentially. And it's like, okay, we don't care about the version, we know that. We care about this middle number, essentially. And they're probably just parsing that, but they're not bothering to convert it to an integer. But, yeah, that's interesting. So, yeah, you get the headers, you have to convert it to a hash. You could actually just call it directly, like content type. It's kind of, it already accepts like hash type keys. And then, yeah, if you wanted to print it in pretty form, it's this weird thing of parsing the JSON. You have to require JSON first. And then JSON parse response body, that's going to give us a hash. And then, you know, if I'm in a REPL like this, okay, I can just do that. I have to look at hash. But if I want to print it in some other format, I can do puts JSON regenerate JSON hash. If I'm creating like a log, I'll probably do something like that to see what it actually is. And that was just a GET request. The posts and the puts are a little wonkier. So I do a new product. URI is pretty similar, but was it the posts? I think it was the puts that were just wanted to so bad. So we have a payload queue post form. And then, oh, I changed my URI, did I? The endpoint is different. Yeah, and so we got a 201 out of that. And there's our response. But updating a product, you have to basically create a request object first, set your form data, so it kind of takes the form of, it's similar to constructing a form of HTML. Change the URI here. The payload is the same. I'm going to construct a request. And I think you can set different headers. They have a few methods here for like set content type. We want to set form data to the payload. And then what's wonky about it's updates and deletes actually. So you have to specify if you're using SSL. So even though the URI says HTTPS, if I ran this without the SSL, it will come back as a 400. So you basically start the request, you give it the host name and port. Should be, I guess it's 80 by default. No, it's 443. That actually makes sense. So if we try running this, we're gonna get some errors, I think. Yeah, so we got a battery. We didn't specify the SSL. So yeah, it's kind of weird that we have to do this, but now that we specified that, we get our 200 response. So puts and deletes. So delete product, same thing. The only thing that's changed here is the class that we're using. So that's net HTTP. There's a few other common clients. So one I see somewhat frequently is HTTP, I can't talk tonight, HTTP party. Goodness. So this looks a lot simpler to work with. Require that now. Okay. And then we're going to make our GET request. And that returns, I think this just returns a hash actually. No, it is a response. Okay, so it prints as a hash. Like the print will show the response body, but the code, this one returns an integer for your code. There's no status, response. And this one includes headers, so the headers are separate, they're distinct. Some of these things have a request. So you can actually, from the response, you can get the request object and see what its options were. So we have some options there. Does it have the headers? No.
The response.
Raw request. Oh, so it actually is reaching out to net HTTP.
They all are.
Yeah.
They're all wrappers around.
Raw wrappers around. Yeah, any other that tracks. So this one has a better interface. I'll just show the post requests. I think I have the payload already in here, right? So you do have to give it the serialized form of payload. So you specify body, you have to serialize it. Some of them you can give it a hash, but this one you have to serialize it. There's our code 201. And then our delete product. So something with deletes, usually, let's see if this will find do. I think it's going to do. Nope. Oftentimes with deletes, you'll get a 204 status back. In this case, we got 200. If you get 204, it means there's no response body. And oftentimes, like what is there to return if you deleted it? It doesn't exist anymore. Let's see what they did here. Okay, so in this case, they just gave us the object back that we deleted. So I guess that's valid too. But sometimes we don't return the object. So another one
That is an interesting choice.
what to return the object.
Return the thing you just deleted.
It's sort of RESTful in terms of like you might want to. Like I could see a client wanting to retain the thing in memory for display purposes, or
Sure, get it.
what's that?
Get it
Yeah,
before.
you get it before you delete
Get
it.
it before you delete it.
Yeah. Most places that I've been at, you delete something, you get a 204, and there's nothing there.
Yeah, because that's a head response. That's not a normal request.
Right.
They're just saying head.
Yeah, there's no body with it or
Delete it.
anything. You're just giving it the ID, the thing, and the delete, and then that's it. The only thing I want to know, and it'll be a different response, is if you already deleted it, then it'd be a 404. You get that. If you're not authorized, you get 403.
Sure.
You can get 400 level statuses, but usually, if it's successful, it's 204. So there's another one called REST Client, which has a similar interface. The problem with this one, if you consider it a problem, is it's not maintained anymore. The last commit on it was like 8 years ago. but it functions.
So I have thoughts on that.
Do you? Tell me more.
Sometimes a library is stable
Because, yeah, it's completely.
and doesn't need to be maintained. So I feel like you take that with a grain of salt, like when was the last time it was maintained? That is an indicator, but not the end all.
Right. I completely agree. That's why I said, like, if you consider it a problem, because, like, it, to me, something low level like an HTTP client, if it's functional and complete, the only thing I'd be concerned about is
It's like if Ruby
changes
changed.
with the language.
Yeah.
Right? You mentioned that they all reach out to net HTTP.
Sure.
If something fundamentally changing there, I can see this getting weird, but I mean, this seems to work well. Yeah, this pretty much has the same interface. REST client, view product. Like almost exactly the same interface. The only thing is for the payload on the posts, you don't have to. There's no key for body. You just give it the payload. Right. And the way they print it here is it's clear that it's an actual REST client response object. It's not a hash. So you have to actually do response body. What does response to us do? Probably just. Okay, so that also gives you the body.
I feel like HTTP party is the same way.
So when we were looking at that, when you made the call, it in the REPL print as a hash.
Right, but I don't think that it is.
It's not a hash.
Yeah,
it's
an
class.
object.
It's
You look
an
at
object.
class, it's an HTTP party object.
Yep.
It just quacks like a string.
Correct. I find this to be a little more clear because it's like, okay, I got a response object back.
Yeah.
Now I need to dig into it to get the body, possibly deserialize the body. Do what I need to do there. And then check our delete. Should we do the same thing? Yep. That's those. And then the other one we're looking at in Bruno is Faraday. Faraday is, it can be simple, can be straightforward. So you can do a Faraday get, give it the address, comes back as a Faraday response object. You can get the body, you can get the headers, you can get the request, but no. I get the URL. So it can be as simple as that. See, I was trying to get the request out of that. Great. Yeah, it didn't like that. There is a way to split this out into, you construct the request first, and then you run it, and then you get the response if you need to have granular control. So I like how it can be this simple, like, hey, just run the get request, get the response, I'm going to do what I need to do there. But if I need to do a post, we're actually breaking it down into, okay, here's the connection. And I can actually reuse the connection for multiple types of, multiple requests essentially. So I can build a wrapper around this for this API. Okay, so when I do this, I have a connection object. I can set my default headers in there. So if I'm always doing JSON, if I want to include an authorization header, I can do that. And then when you do posts, you typically in this block format, you can give it a path, and then you get the request, and then within here you can specify in your request headers, your body, and then the result of that will be your response.
Do you go over the middlewares at all?
I'm familiar with them, but I don't have an example of that.
So like if you look up the Faraday JSON middleware,
Mhm.
what you can do is you can add it on the connection, and then if it's a content type of JSON, it just auto parses it.
Okay.
So you don't have to do that thing on your response. I go back and forth on it because it's almost the same number of lines. So maybe if you were newing up a client, like to be used more than once, it makes sense. But it's also like effectively the same number of lines.
In their example, they created a new Faraday
Yeah,
object.
so if you say like
They
on
open
there,
the
if you
block,
pass it a block,
so they can do, I'll just comment this out so you can compare. Connection is Faraday new. Oh, it's Faraday. So Faraday request is JSON.
so you can do, it's the same. You're just passing the block with the request.
What do you mean?
Go, you didn't like pass it the URL or the header.
Right, I was looking for the exam.
It's the same as 7 through 10.
Okay,
So all you're doing is opening it up and
but I
saying,
can still do URL here, right?
yeah. So you need to still add your header.
So then what's the benefit of specifying the middleware?
Oh, that's for request. I don't know. I do response. So if you say, I think it's Faraday response, dot response, 15,
Oh, response.
try that. And then that should give you back.
Oh, so okay, so instead of doing it down here,
Yeah, so then if you just do your post, all you care about is that I'm making a request. You don't care, it's gonna get parsed based on the content type. Cannot post.
yeah, because
Objects
the connection.
Oh yeah, you still have to put your headers in. That's different than the parsing. You have to tell it what to do.
Okay, right. So the request headers are the same. It's
Yeah.
just what we're accepting is JSON. So we don't need to.
Yeah, you're saying I'm gonna parse it as JSON when it comes back, because I'm asking for JSON.
I see. So we're not having to do this extra step here.
Yeah, but see how it, so get it to work, but see how it's effectively just the same number of lines.
How is it? So what I was doing here is I was generating the JSON for the request payload.
Yes. It's going to JSON parse the payload, the body. Cannot post. What's going on here? Connection new.
Because I'm still sending up.
Go back to the docs.
Oh, they're not giving it a body. Where do I put the body?
Yeah, the request is not finishing.
So like if I do things where I'm lost, like I know I'm getting JSON back, but where do I pass the
Go back to the
payload?
middleware docs for JSON.
Yeah.
So there should be.
Oh, so you pass.
Oh, JSON encoding, decoding, right down. You're in URL encoding.
Mm-hmm.
Go to the side. It's like 2 entries down.
This.
Yeah, that one. So F request JSON, and then you just post. Yeah, so it is a request JSON.
Right, so the request JSON, and then I can just give it a hash.
cannot post.
Let's look at this. We already knew. That's JSON. We already knew you would need URL.
Oh yeah, response. That's what I want. So it
You
wasn't
have to
right.
do both.
Well, I never use the request one, I just do the response, but. Cannot post to projects add.
Oh, wait a minute.
Products, you typed it wrong. The one that's commented out on 21 is products. You've got projects.
Yep. Call out. Okay, there we go.
Yeah, so then it auto posts. And now that you did request JSON, you may not have to put the content type. I'm not sure.
Let's try that again, see what we get this down to. Yeah. So the connection headers. It's weird, it doesn't include.
Yeah, you'd have to look and see what the request option does. I just know the response is telling it to parse out the JSON.
Yeah, see, that makes sense. We're getting that. We see in the response body, we got a hash. We didn't have to deserialize it.
Right.
Just wondering what this does. Oh.
What's there?
Yep. So we did need.
Body size.
Yeah, right. So we do need the request because, or we don't need it, but this is telling it to serialize the payload. So if I did JSON generate.
Oh, yeah, because you're giving it a hash and not a
Yeah,
JSON string.
so now it should work. Right. So the request is saying what we post, we're going to give it as a hash. It's going to serialize it as JSON, and then on the other side, when we get the response, we're going to
Yeah, we're
going to deserialize that JSON into the hash.
It's like a Marshall load and done.
Yep. I do like the way this reads better though. But yeah, I mean, that's a clear exercise. So like Faraday, you can get like middlewares, you can mess around with the connection and the request, have common reusable things with the connection, whereas the others are more like you're using HTTP party, you're probably just doing one-off requests. I think you actually could make with party, you can make like a wrapper class and then include party, and then you can make like your own like, you know, API.get, API.post.
I've done that a lot. There's the way the macros are set up for like authentication headers and stuff like that, they're static. And so there's not a great way to inject something. Say you keep your credentials in Rails credentials.
Mm-hmm.
And then you have the class using the macro of the authorization header.
Okay.
It has to be a static value. It doesn't like pull it on the fly. It's weird.
So it has to be at, you want to hit build time, but it has to be static because
it has to be a static value.
So when you start the application, it has to exist somewhere.
And I tried a ton of stuff. I tried giving it a proc, and it just doesn't. So I ran into some weirdness with that, but it might have been the way we needed to use.
Could you read? Maybe it's bad practice. Could you read the credentials file at server start and just put that somewhere?
I think it'll work if it's like straight credentials, like build time. When the class is read, if it has access to it, it will read it.
Sure.
We had where it was, we were making a request on behalf of someone that was making a request into the system. So like the key could
You're
change.
boxing the request and it was,
And the macros don't work like that. It has to be like when the class is read. So that was a bummer. But other than that, yeah, you can make your own little API wrappers with HTTP party.
yeah,
And all it is just include HTTP party.
yeah. It's been a while since I've done that that workflow. I've used Faraday more frequently. Just
Use Faraday a lot. I don't know how I feel about it. It feels more confusing than it needs to be.
I think that's probably true.
There's another one that is used in a lot of other libraries called, I think it's just HTTP client.
Okay.
It's supposed to be simple. If you want to look it up,
Yeah.
it's used in a lot of gems. And I feel like that's also a simple interface.
Is it this one?
Yes, I believe so. Maybe.
Let's try it out. Go jump on. This is just a project of different clients. Here, bundle.
It's like a normal Rails project. Every library you pull in is made a choice on which HTTP client they're going to use. So like any given Rails project could have 3 or 4 or all of them in there available
Yeah.
to you.
I tried to list too. I think we have both Faraday and Party.
Yeah, it's not uncommon.
We'll just stay in here. So we're in the car. It's basically a scratch pad at this point. CP. Show the RB. So let's see. So we can do a get. So I want to jump around and get the URLs. So what was the syntax? HTTP get. Okay. So I like the way that prints. You get an HTTP response object, tells you the version, tells you the status code, the reason, and then it looks like it's trying to print the headers.
You're on like a modern Ruby, right? 3 something?
What version am I on?
That's fine. You just try it doing like an LS.
321.
I think that'll work. Try LS response.
Yeah. Seeing they give you the common ones, like content length and type.
So check like, so there's code and status. So like, let's see what the difference is between the two. So code is a number.
Yep.
What's status? Also a number.
That's just
So they're interchangeable.
Oh,
But it's kind of like refer and refer.
Yeah. There's reason though. So they see that's what okay.
That makes sense.
Actually, it makes that is what it's called. That string is called a reason. So I think that's valid. Either I think it's RSpec or some. I don't think RSpec where like status is the reason. I don't know. So I always get that mixed up though. See response.
Oh, like when you're doing testing?
You want to
so you can say like to
response.
have HTTP status,
Yes.
and then it's the symbol,
of the reason.
of the reason.
Yep.
But that's common, because those symbols are matching the Rails codes.
Right, so the status you get back is actually the code, right? But then
Right, so you can say,
when I say, oh, the reason is okay, it's actually mapping it back to it's mapping or
the Rails
to
hash.
200, yeah.
Yeah.
Okay, so we freezing request status request, so I can actually, if I didn't preserve.
Yeah, so do an LS on that, because this is something that Faraday kind of is a bummer at. Getting back to the request that you've made.
Well, I think it's like, I don't know what, maybe I just didn't read the docs enough yet here, but like what if I wanted to construct the request first? Because I think that's what Faraday shines at, is like you can build up your request, and then once everything is placed, you still have that object, but then you can execute it and you get a response back.
Well, take a look. Take a look at
to the docs. Because here you're just, once you run get, you're getting the response.
Could be.
Oh, here we go. Here we go. The real docs, making requests.
So it has normal sugar methods. Is there just a new? Like do an LS on HTTP.
No. Understood.
So build requests probably it.
Oh, is it build request?
Yeah, so I'm guessing it's gonna take the method, the type. Just do a search to like def build request.
They use show method for?
And oh yeah, you can do that.
Oh, yes.
Oh, did that actually work?
No, it didn't work. I might have something else.
Because there's a difference between debugging and product.
I think that's what it is. I'm in IRB.
Yeah.
States the verb, the URI.
Okay, so that one, verb URI.
Verb. I don't know, URI is like an actual URI object, or it could be
Make request URI with URI. So just source dive. What does that method do? Does that wrap it, or does it need to be a URI? URI toString, so it needs to be a URI.
Okay.
Well, no, I guess it doesn't have to. Go back. So on line 143, it's saying whatever you are, turn it into a string.
Oh, because it's going to make its own one.
But then on 147, it's parsing it anyway. So whether it's a URI or a string, it's going to be turned into a URI. So you can pass the string.
Yeah, let's try that. So request is HTTP build request get, and is it then ops default?
I don't think it needs it.
Yes. Okay, so I don't need to pass it. Get rid of that. Okay. Request.
So now you have a request object. What can you do with it? So ls request. Stream, verb. So you probably, oh, that's interesting. What would you do with that? You probably, I would think, just on instinct, that you would then like HTTP verb the
Oh, it's like
instance?
pass that into.
But then why would you have to pass the verb in the building of the request?
No.
Unknown
Hold on.
scheme.
Let's do this again. Step op connect request HTTP request. Nope. Follow. Nope.
go look at the source.
Perform.
Perform request with options. Yeah.
Was that in here? Perform?
I don't remember seeing it.
Oh. Did request have a perform in it?
No.
So this is the client object. So maybe it's
It's LSHTTP. No, I think it's just there. It's the client file, but the module is defined as HTTP. I think it's just straight up. Oh no, it is client.
yeah, it's
With
client.
forwardable and chainable.
So
it's a
you,
delegator.
but you have to initial. It's an instance. So
So build
I'd have to
request.
initialize it with. Interesting. So I guess we do like new. Perform. What else does it want? Scroll too far.
Where does build request get used? This feels like something that's getting used elsewhere.
Yeah, because I didn't call build request through this. I called it through.
Doesn't perform require a request object?
Yeah.
It does, but I did HP build request, right? Did not this
we're in
class.
we're in a different one, yeah. So
So
go back to the other one we had.
was there a different build
There must
request?
There's a chainable and a client
So
with the given verb.
this is probably a password. I don't know what branch does.
Timeout. So look at where the get and post methods are being defined, and see how those are creating requests.
I think it's these. It's creating. It's actually creating.
So request,
Or a request
post,
on its
URI
own.
options.
But then it's actually. It's calling request, but it,
Okay, so then what is request doing in here?
I think that's this. Because this had a request too.
Yeah, but there might be.
Oh, so
many.
request is using build request, and then okay, so and it in turn is calling perform, but perform I think isn't exposed in chainable. Perform. Yeah. So branch is creating a new.
New client.
Yeah. And then so they're creating a new client object with whatever options you passed in.
Although go down, there were some comments in retrieval. So retrieval, get. Retrieval, get.
Yes, they're
So
retrieval wrapper.
Yeah. So what would you want to build the request first for? Like just setting off headers or something? Headers?
I could do without it. I think it's if I need to like if I'm debugging it and it's not clear what the headers are. Like I'm looking at, say I'm in a pry and I'm looking at the response and respond to something that is off, and I want to know what got passed in to begin with. And especially if the client is defaulting headers in some way.
So because you have to pass everything in at the top level, it feels like everything would be very exposable. So maybe that's by design,
Right.
that you
Well,
don't have to do those
and
things.
but going back to what we were doing initially, the response actually includes the request in this case. So I could do without it. I was curious about separating it out.
Right, but think about Faraday, where it's hard to get to the request from the response.
Correct. Yeah. This has.
This gives you easy access.
Yep. This actually includes it right there. Faraday apps. I have to create it. I have to do this whole connection stuff first. That setup, and I kind of have the request there, but I can't actually get it out of the response. Where here I can.
Yeah, so different goals for the project. I think that, Faraday in the long run is more powerful. But if you're just looking to make easy to read requests, HTTP party, HTTP,
Definitely.
their APIs and lots of stuff.
Cool. Let's see. We're almost at 8 o'clock. That went by fast. Trying to think about what else we can cover here. I had some notes on REST. I'll probably just kind of skim over it. Maybe I'll probably do another talk on this at some point. So you hear the term REST or RESTful APIs. REST is representational state transfer. It's considered an architectural style, not a standard. I often call it a standard, but people ask you, is your API RESTful or does it conform to REST? We're talking about these 6 guiding principles. So uniform interface essentially is talking about the way I'm interpreting it anyway is, are the methods you're using and the paths that you define, are they consistent and are they descriptive? So they talk about identification of resources. So is it clear that you are creating a new resource or you're referring to an existing resource? And then same thing with the messages. Is it consistent? Is it descriptive? Client server. This essentially means that your client server should be seen as 2 different applications. This one's hard to quantify if you are, like, say you have an API backend powering a front end on some, name it, any JavaScript framework, React, Vue. Oftentimes those applications are, to the end user, they're seen as one, and oftentimes we might make deployments at the same time with those. They are different applications though, and if you were to swap out a web front end with a mobile front end, then this one becomes more important because mobile applications definitely have a less frequent release schedule than backends. Backends can often deploy at whatever we want, but mobile applications go through a review process, and so you often have to maintain different versions of your API for the different clients. This is just talking about keeping clients supported, making sure they don't break. Stateless, so basically the requests and the responses should be complete. They should have all the context needed within them. They shouldn't have to rely on previous requests or previous information to do its job. If you're using caching, the response should say so. If if it's cacheable or not cacheable. Layered system, this is mostly API architecture, saying that you should have a layered architecture like an MVC, so that separation of concerns is clear. And then code on demand. Once again, if you're doing like strictly data APIs, this is not as common, but you can send code essentially for your client to run. Definitely like a full stack traditional application. If you're sending JavaScript resources, I guess that complies, but it's not really you're not really doing APIs at that point per se. So this is a good, but anyway, this is a good site to go through every so often, even if you're doing API development regularly, just to see, hey, what is REST? What do they recommend? There's some good things here on pagination and filtering, how to use query parameters, links. They talk about how to use different status codes correctly. They talk about idempotency. Every request should be independent. So they talk about post and patches will not be idempotent because you're actually changing something, but your get requests, your header requests, they should be they should return the same thing every time, until something changes by another request or from some other action. So these would always be safe. But yeah, I think that's all I have for now. I have content on other standards like JSON API and GraphQL. That's probably more than enough time for tonight.
Definitely different subjects.
Yes.
Okay. Bravo, sir.
Thank you.
Did you get all that
Very
done?
cool. Yeah. Yeah, it brought me back to, I mean, I haven't done it in a while, but when I was working on the other team and doing Ruby and trying to troubleshoot HTTP requests and stuff, that you brought back a lot of memories, Ryan. Trying to troubleshoot and figure out why stuff wasn't working the way I thought it should work.
It'd be a tricky thing to debug. As I was on one company, I was at one company where we were supporting a mobile application, and then it was constantly the mobile team telling us, "Hey, your API doesn't work." And I'm like, "Okay, what are you sending us?" And
Yeah.
they had the code from the client that they were using, but I was like, that's not the requests. Your client's object is not the same as the request. So trying to get that out is can be a bit of a challenge. I found that headers are often auto set. So great example is just look at a browser. I'll reshare for a moment. Your browser sets a user agent, right? So probably open this page right here and go to network. Refresh this. We should see whatever it's requesting for the document inside. There should be a user agent, right? And that it actually looks confusing because it includes in Mozilla, which is the browser, but also includes some information on the operating system. And some of these are, I don't know how they come up with these names. So if I go to Chrome and I go to the same URL, I think it actually includes the word Mozilla somehow. Like it includes, did I get rid of Chrome? There it is. So we're at 2. It is different, but you have to read that user agent carefully because it indicates the browser. It can indicate version. communicate the operating system. I don't think it always does. It doesn't always. Top one. Yeah, so it says Mozilla 5.0 on it, even though we're not on
Yeah,
Firefox.
right.
But here's the important one, Chrome version 141. So I guess there's some shared user agent stuff here. I guess it's like compatible with, is there anything what browsers are essentially compatible with? But this is an example of a header that automatically gets set for you by the client. And so different clients will do this as well, not with the user agent, but also with some other headers. Like there's sometimes they'll do some auto caching, and that because it's sent up in the request, the servers can interpret that differently. So just the client making the request can impact what type of response you'll get. It's not strictly, oh, am I making a GET request or a POST request or URL or authorization, right? That's stuff that we would normally set manually. It can be client-related things too.
Yeah, I remember we had a lot of issues or frustrating issues back in the day with the JWT stuff, the web tokens. And it was helpful to be able to drop down into Pry or IRB and troubleshoot.
Yeah, for sure. That's why they're useful to see the requests, like especially on you're on the back end, you're connecting with something, and you want to compare what did I send up versus what did I get back in response.
Yeah.
All right, that's all I got. I'm gonna stop recording.